are not with us can find this later if I ever get my act together and actually put it someplace you can find it. Yeah. Next year's class will benefit. Summer project for me. I'm kidding. I'll get it up soon. I promise. They even tell you where it is soon. If you're really desperate for a video, like you missed the class that day, and you really know I made a video, which is 50-50 at best, you can go to YouTube channel, look for Mr. Resni's channel, look for the latest one. Don't look like there's 600 something videos there. You don't want to look at. You want to start at 601 and work your way back that way. Just the latest one that's in there is probably from the day I did it. I upload the same day, so that sort of thing. All right, so I'm going to do this problem. It's going to be fun. We know how to do this because we're looking at it. I'm going to use who's common denominator trick and everything. So they just multiply this by 2. Is that okay with everybody? Multiply that by 2? I can multiply and cross. I get the same answer, but is it okay if I just do 2 top and bottom? Okay, let's do it. So I got 2 as 4t plus 3 over 4t. And I'm going to ignore my greater than 1 because I'm going to check my answers at the end and not worry about this inequality thing. There are some rules associated with when you have a t on the bottom that you don't want to play with inequalities. You really don't. So you're much better off just kind of saying, all right, fine, I'll make the equal sign, I'll solve it, and then I'll go back and figure out what the answer is. Does that make sense? Greater than or equal, and I can figure out once I find the boundary. Okay, I get rid of 4t on the bottom, multiply both sides by 4t. Not top and bottom, just 4t, right? When I do 4t over here and 4t over here, this gives me cancel out with those 2, and I get 2, or I could have added those, couldn't I, first? That would have been a smart move to do. Where were you guys when I was doing this problem? Okay, 2 plus 3 is where I left that. It's equal to 4t, that's great. 5 equals 4t, or t equals 1.25. I went the last part fast, so I'm going to pause a moment. Whew. So, oh, oops, to writing. I'm going too fast. All right, here we go. And now I'm going to figure out whether it's greater than or less than. Agreed? So basically, I know it's going to be t, and it's going to be 1.25. It works like everything we did in Algebra 2 up to this point, and Algebra 2 is absolutely true, so it must work this way. Is it greater than or less than? How do I find out? Check a point, right? Check a point other than 1.25. Who said plug it in? You get to pick the point then. Oh, let's draw a number line just so we recognize what we're doing. We've got 1.25. It's not equal to it, so I'm going to put an open circle there, 1.25. Pick a point to the left or the right. Probably pick both. Okay. Let's go. 0.9. 0.9? I know, but why 0.9? Yeah, I'm going to go 7 over 121. Come on now. You got 1, you've got 0, you've got 5, you got 4. How about 2? 2's okay. I'll take 100. Let's do 100. 0.9. All right, we're doing 0.9. Let's see how that goes. All right, 0.9. 1 over 2 times 0.9. 1 over 2.9 was 1.8. Plus 3 over 0.9 is 3.6, is greater than 1. Right? Common denominator gives me 2 over 3.6. Plus 3 over 3.6 is greater than 1. I can combine, I get 5 over 3.6 is greater than 1. Is that true?
Yes.
Yeah, because the top's bigger than the bottom, right? So that's true. So it's true. So it's got to be true at 0.9. So I'm going to assume I draw it this way, correct? Yeah. I should check the right-hand side just to be sure. Pick a number bigger than 1.25. You can be nice this time.
5.
5. Let's do 5. So I got 1 over 2 times 5 is 10. Plus 3 over 4 times 5, which is 20, is greater than 1. Common denominator, I end up with 2 over 2. So I get 2 20ths plus 3 20ths is greater than 1. 5 20ths is greater than 1. Is that true? That is not true. So therefore not true. So I feel really good about my answer and I just got it wrong. How can I get wrong? It's not possible. I just did everything exactly you did. You did everything beautifully right. let me suggest another point. Let's do -1, shall we? Let's just do -1 for a moment. I'm going to plug in -1. If I plug in -1, I get 1 over -2 plus 3 over -4 equals greater than 1. Sorry, greater than 1. Okay, combine like terms, I get -2 over -4 plus, I shouldn't do that. That's even more confusing. Let's just do -2/4 is fine. -3/4 is greater than 1, so I get -5/4 is greater than 1. Is that true? Is -5/4 in fact greater than 1? No. Well, how can it be? I don't have another solution. There's no other place it could be. We started talking a moment ago about discontinuities, places where the function falls apart. When the function falls apart, it creates another natural boundary. So, for example, if I pick 0, what happens here? I get 3 over 0 plus 1 over 0 plus 3 over 0 is greater than 1. I get undefined plus undefined is greater than 1. Huh? So there's another boundary here. And the boundary is where the thing turns discontinuous. All right? So let's see if I've got everybody with me. I'm going to start off by asking a question 2. I'm not going to ask a question 2. Oh, Combs. Yeah. Combs. Where does this thing go haywire? When t is equal to what?
When t is equal to anything greater than 1.25.
Well, we know it doesn't work there. That's our usual thing. We know that, right? It's just too big a number, right?
Yeah.
What about, where's it going haywire on the left-hand side? Because we thought we could just simply go this way, but we can't. We get stopped by something. What do we get stopped by? When t is equal to what?
Was it -5?
Oh.
No,
It's when t, yeah, when t is equal to 0, when t is, this problem melts down. It becomes undefined plus undefined is greater than 1. That doesn't even make sense, right?
Yeah.
So we know it makes a boundary. So here's the new thing. It's not really new. Technically, you talked about in algebra 2, but the algebra 2 teaches you to do this. They go, and so this is correct, and then this is right. Because we don't want to talk about this. But you're in trig pre-calc now, so we get to talk about all the weird stuff. Here's the weird stuff. Where it turns discontinuous, you need to put that on your number line. So in this case, what makes this thing equal to, makes the bottom go weird? 0, right? We know we can't have 0. 2 times what gives me 0? 0 does. So I put 0 on my number line. It can't be equal to 0, I know, because that's where it's undefined. Once I do that, I'm going to check 3 places. I'm going to check here, here, and here. Does that make sense? So the only thing new is you have to go find your discontinuities and put them on your number line and then guess left, right, and middle. Does that make sense? Okay. And as such, now that I've already checked this is not true, but this is true, I can write my answer as from 0 to 1.25. Now I got to talk about this notation to make sure you know this notation. Do you know this notation? Raise your hand if you know this notation. I've got 3 people, 4 people. Okay, that's not a good enough number for me to be happy. Okay, so what the curve bracket means, not 0, but everything to the right of it. And this means not 1.25 because it's curved, and everything to the left of it. So this means everything between 0 and 1.25. It's the same thing as this, which you could also write if you want. That's also a solution. Is that okay? Now, those of you who are juniors, and if you're a junior and you're in this class and you don't take calculus next year or stats, I get to make fun of you for eternity because what a waste. This class is to set you up for that, so you don't have to take math in college if you don't want to, or if you love math, to get you set up so you're ready to take math. You need to start looking at it this way. Okay, the curve brackets made round circles. That's why they're curved. Square brackets would be filled in circles. And you just write where it's true from. You know, it's true from 0 to 1.25. And you write curve brackets saying not including those 2 endpoints, okay? But if you want to write all your answers like this, I will not mark it wrong even once, not even close. You're all good. Okay? I see some blinking. Are we okay, Noble?
Yeah.
We are?
Yeah.
Okay. With that in mind, everybody try number 9.